Hi there, welcome to your second webinar. In this webinar, we're going through 6 different topics and we will talk about each of them more thoroughly. At the start, we will talk about the introduction to NLP, which you will learn the overall pipeline of all of the NLP algorithm. Later on, we will go how to fetch a data from a website, which in this case, you do not need to actually download any data, so and it will save you tons of time. Thirdly, we will go to text processing. As you know, before putting any type of data into our neural network, it needs to be pre-processed, and the pre-processing steps are different, like either in text, either in images, or either in numbers and values. And here you will learn all of the steps you need to take for text processing. Later on, we will talk about Bayes theorem and naive Bayes, which is a very useful algorithm. Even though it's more traditional, it's not really new, but it's very useful to solving a lot of new problems. And we will do this all of that by using only hard-coded without using any library. So you will actually learn everything about it. And at the end, we will talk about spam detection in here, but we will use scikit-learn library, which it makes the whole process so much easier and so much faster. Before actually starting it, I just want you to take notice that at the end of each part, you can find resources, as you can see. And also, if you go at the end of the Jupyter notebook, I included some notes for those of you who don't have so much time for taking notes. For example, if you click on it, I went through all of the videos in the Udacity. I take a screenshot and I wrote comments for those of you who do not have time. So still, it's very good for you to write your own code, but this is a great resource as well. Okay, let's start. For approaching any type of NLP problems, you need to do 3 steps, which this 3 step is also called NLP pipeline. At the very start, we will get our raw data and we should apply the pre-processing steps to it. And in this Jupyter notebook, you will learn thoroughly about it. You will learn the exact steps you need to take. Secondly, the second part of our NLP pipeline is feature extraction, which in here we will take relevant features, which later on we've put it in our neural network. And this step is different for in any type of problems we are trying to solve. For example, feature extraction in spam detection is different than feature extraction in a machine translation. And any type of problem has its own feature extraction, which you will learn thoroughly about this on the second part of your nano degree. And at the very last steps, we do modeling, which either we put the extracted feature in our neural network, or we put it in a more traditional algorithm, like hidden Markov model. Okay, now let's go to the second part of this Jupyter notebook, which we will talk about how fetch any type of data set from a given website. In this example, we will go to the TechCrunch website, and what we want to get here is to get the title of all of the news, which is this, and the rest. And the way we do this is to using a request library, which let's import it. Requests. And for getting the data from the website, what we do is to say request and we use .get. And in the .get inside of it, we use the URL of the website. Let's copy paste it. And for seeing the text of it, we use r.text. Let's take a look at it. As you can see here, we got all of the data, which is JavaScript, HTML, CSS, and all of it is here. And a lot of these tags are irrelevant to us and we don't want to use them in future at all. And the way we delete this is to use a library called Beautiful Soup. Now let's import the library from PS4, import Beautiful Soup. Okay, now let's delete it. Beautiful Soup dot Beautiful Soup. In here we put the text of the data that we fetched before. We say r.text and we say HTML5 lib, which we want to delete all of the tags related to the HTML. And let's take a look at our data. Soup get text. And as you can see here at the start, we still have some JavaScript, but if we go to, if you take a look at the HTML part, here you go, you can see that all of the HTML tags got deleted, but still, as you could see, there's still some part that a lot of irrelevant code that we want to delete it. And let's start by actually getting the titles. And the easiest way I can suggest you for getting a specific part of website is to actually go to a website. For example, if you want to get the title, just search this on the code and let's see it is inside what type of tags is it. For example, No Man's Sky, No Man's Sky. Okay. Okay, as you can see here, this title is inside one anchor link, and also the anchor link is inside h2, which this tag shows title of all of the news articles. And the way we get all of the titles is to fetch every h2 with the class of post block title. And the way we do this is we say, let's say soup, and we use find all, which inside this at the start we put the tag we want, which is h2, and then we will say the class, which let's copy paste it. So let's say summaries. Take a look at this. As you can see now, we got a list with all of the h2 tags, and all of our titles are in here. So the way we will get let's start just by taking a look at the first item in our list, which let's say summaries 0. Okay, the way we will get this title is to write get text. And as you can see, we got our title, but still we got some space, like here we use tab, that we really do not want to use this. And the way we'll delete all of these spaces is to use strip. Voila. As you can see, we got the title of our first item. Now let's go and actually take the title of all of the articles. Say articles. Let's loop over all of the summaries. And copy paste this, and instead of using this, we just use I. Articles. As you can see, we got all of the titles in the first page. All of the titles. And in here, you can see some further resources if you like to learn more about how to web scraping. Okay, now let's go to the third part of this Jupyter notebook, which is text preprocessing. For text preprocessing, you only need to take 5 steps, and after this 5 step, you're good to go for the feature extraction. The first step to clean the dataset, which is delete all of the HTML tags, all of the JavaScript, which we already did in a previous topic. The second part of the text preprocessing is normalizing the text. Normalization is different whether you're doing it on images or on numbers and values or for the text. For the text, the way we do this is first we lowercase them, we remove punctuation, which is something like question marks, and at the end we tokenize the text. Okay, now first, this is the text that we are going to preprocess it. Now let's normalize our text. Dot lower. As you can see, all of the words in here got lowercase, like you don't have these capitalized words anymore. Then we will remove all of the punctuation, which we can do this with regular expression, which is RE. And for removing the punctuation, we can say sub. And here we want to say that delete everything that is not a lowercase letter or uppercase letter, and also not numbers. For example, let's say this means not. Delete everything that is not lowercase letter, uppercase letter, and numbers. And if you see any characters that are not these the mentioned characters, then replace them with the empty bracket. And we want to apply this to our text. Okay, now let's take a look at it. Now, as you can see in here, all of the punctuation has been deleted. For example, this is a question mark that you cannot see here, or full stop that you cannot see. All of it got deleted in here. And the last step of normalization is to convert our text into tokens. We can do this by just saying that split print. As you can see, all of our text converted to a list of words. However, there is a better way for tokenizing, which NLTK has it. In this way, our tokenization becomes more smarter. Now let's import it. Tokenize. And I really suggest you to, instead of split, use word tokenize from NLTK. Sorry. Oh, Okay. Okay. Now, after normalization, we go to remove all of the stop words. What is a stop words? Stop words are words that appearing a lot in our text and we want to delete them in order to avoid any overfitting for our dataset. If you want to take a look at what is exactly our stop words, NLTK has it. We can say from nltk.corpus import stop words. Now let's take a look at it. Stop words English. Also, NLTK has stop words for other languages as well. That's why we in here we specify English. And these are all of the stop words that we will delete it. Okay, now let's loop over our tokenized data and delete everything that is a stop word. Okay, let's say for I word in text, if I word not in stop words. Okay, let's say okay. Now in here we deleted all of the stop words. As you can see, there is no day in here, or all of these stop words got deleted. Okay, now the next step, as a fourth step, we apply stemming. Stemming simply means to delete all of the suffixes from our words. For example, in here, branching, branches, and branch, what we want to do is to delete this ing, es, ed from our word. And the way we do this is, again, we will use NLTK from NLTK that stem dot porter import porter stemmer. Let's put this print. Okay. Now again in here we will loop over our words and we will apply this stemming to each of our words. Let's say stemmed for I word in text, apply porter stemmer that we just imported it. We say stem I word. Now let's take a look at it. Okay, here as you can see, like imagine boring, in here it turned to bore, which we will deleted these suffixes. The last step of text preprocessing is to apply lemmatization. Lemmatization, it means to convert all of our words to its root form. For example, converting was, is, were into be. And again, we will use NLTK for doing so. So NLTK stem wordnet import wordnet lemmatizer. Okay, in here also one thing to notice that lemmatization, if we want to convert nouns and verbs, it needs different steps. So let's first apply the lemmatization into our nouns. Okay, lemmatized lemmatized I word, and we say part of speech n, which is noun. Now let's loop over to our list in here. I word instant. Take a look at it. It might take a while. Okay. Now we limitize all of our word, and for limitizing the nouns, we can copy paste it. The only thing that we need to change only to put part of speech to V. Also, let's apply it to our limitized list that we have just created it. And in here now we have our pre-processed text, and we are ready to the next step of the NLP pipeline, which is feature extraction. And if you need any further resources for text pre-processing, you can read these texts that I share with you. They're great resources. And also you can take a look at the note as well. Okay, now let's go to the fourth part of our Jupyter notebook, which is about Bayes' theorem. What is Bayes' theorem? Bayes' theorem is when we have two sets of probabilities, one prior and one posterior. Prior means the probabilities that they give us at the very start, and posterior is the probabilities that we want to compute after considering all of the evidence. And let's actually explain this with an example. Let's say we want to make an example about having a cancer. We go to a doctor and they tell us, after taking the test, they tell us that we have a positive result. After that, we go to internet and we will figure out that only 1% of whole population have cancer. And also we will figure out that this type of test usually have 90% accuracy on those people who actually have cancer, which is also called sensitivity. And also we will figure out that it has 90% accuracy on those who do not have cancer, which we will call this case specificity. And let's write this data, this information that we get in here. As you can see, the probability having a cancer is 0.01 because only 1% of the population have cancer. And there's also two sets of probability of getting a positive result and probability of getting a negative result, which later we will compute it. And also in here we have probability of positive given cancer, which means probability of test being positive on people who actually have cancer, which is 0.9 because it has 90% accuracy on our sensitivity. Also, probability of getting a negative test result on people who do not have a cancer is 0.9 because there's 90% accuracy for our specificity. And if you want to write the Bayes theorem formula, which is it's all this, we only want to compute this. This is our posterior probability that we want to compute, which is probability of having a cancer, and actually given that we actually got a positive test result. And in here we have to put all of this together to at the end get this posterior. This is our goal. And now let's take a look at probability of being positive given cancer, which we already got, and we can use 0.9, we put it here. And probability of having a cancer, which is here, which is 0.01 because 1% of the whole population have cancer. However, we do not have this probability of being positive, which with this data we can compute it, and the way we do this is with this formula, which is probability of having cancer multiplied by sensitivity. Sensitivity is this, and probability of not having cancer and specificity is this. So at the very start we will compute this. After that we have this probability of having positive, we just insert it in here, and at the end we will get our posterior probability. So let's start. As you can see, probability of having cancer is 0.01. Let's put this here. Probability of cancer 0.01. Probability of not having cancer is simply 1 minus this. P of no cancer is 1 minus this. And probability of being positive given cancer, which is our sensitivity, we can take it from here, which is 0.9. Probability of positive cancer 0.9, and also our specificity is 0.9 as well. Let's write this down. Probability of negative no cancer is 0.9 as well, and we will write this based on this formula. So how is it we're gonna write it? Is P positive, we will multiply the P of cancer by sensitivity, which is P positive cancer, and we will add it to a probability of not having cancer with our specificity. Okay, now let's say print. Now let's print our result, which is probability of getting a positive result is equal to okay. As you can see, there is 90% is probability of being positive. And so now that we have this P positive, we can go on and actually calculate our posterior, and we want to compute this. Another way of writing this formula is like this, which we put sensitivity instead of this probability of positive given cancer. And also we want to compute the probability of not having cancer given positive. Okay, now let's calculate the probability of having cancer given positive, which is this first one. And the only thing that we have to do, we have all of this, we only have to stick them together. So let's say probability of cancer positive equal to probability of cancer, which is this, multiplied by sensitivity, which is probability of positive cancer, and then at the end we will divide it to the probability of actually getting the positive result, which is P positive. So let's also print out the result. Which this is the probability of having cancer given that we got a positive test result. And in here we just divide we will multiply by 100 to get the actual percentage, which is 1%. Now let's calculate the probability of not having cancer given that we got a positive test result. I'm sorry. For getting the probability of positive, I forgot to, in here, we put 1 minus specificity. Sorry, one minor change. Which after this, we get the 10%. And probability of getting cancer given that the test result is positive is 8.33. I apologize for that. So now let's calculate the probability of not having cancer given that our test result is positive. And again, like this, we use the formula in here, which we can simply say probability of no cancer positive, probability of not having cancer, which is this, multiplied by 1 minus specificity, which is 1 minus p negative no cancer, and at the end we will divide it to the probability of being positive, p positive. Now let's print out the result. P cancer given positive, or probability of not having cancer given that the test result was positive. And as you can see, there is 91% of not having cancer and actually getting a positive test result. So now we calculated both of our posterior probability, and that was all to our Bayes theorem. If you understand this, you understand the whole Bayes theorem. And if you need some extra resources, I especially will suggest you this from Udacity, which is a free course you can take, and just learn the Bayes theorem part. It's a great resource for learning. Okay, now let's go to the fifth part of this Jupyter notebook, which is about naive Bayes theorem. Naive Bayes theorem is literally same as the Bayes theorem, but with only this difference that we are naively assume something. What are we assuming? Udacity video gave a very good example. For example, in here, let's say probability A and B is equal to probability of A multiplied probability of B. This is only true if probably the event of A is independent from the probability of B. And in here, we are naively assuming that they're always independent. For example, let's say probability of A is that how cold is outside, and the probability of B is the probability of how hot is outside. And these two are dependent to each other. If one goes up, the other one goes low. But in here, we don't assume that. We assume these are always independent, which is a naive assumption. Now let's explain this more with an example. Imagine a political candidates which they wanna. Imagine we have two political candidates, one Jennifer in one party and one Gabriel in another political party. And we also assuming that the probability of each of them giving a speech is equal So in here we will consider probability of Jennifer giving a speech is 50%, and also probability of Gabriel giving a speech is 50%. And also we want to see the probability of each of these candidates giving each of the words liberty, war, and economy. We want to consider them. And let's first start with Jennifer, which the probability of Jennifer saying the word liberty in her speech is 10%, and the probability of saying the word war also 10%, and the probability of saying the word economy by Jennifer is 80%. Now let's consider the probabilities for the Gabriels telling these three different words. The probability of Gabriel says the word liberty is 70%, and the probability of Gabriel saying the word war is 20%, and the probability of saying economy by Gabriel is 10%. Now in here we want to naively assume that there's only saying the word liberty and war, and with Bayes' theorem we want to calculate the posterior probabilities. The formula for the naive Bayes is this that you can see here. Probably the y, we can consider the y for each of the candidates, which in here it can either be Jennifer or Gabriel, which I wrote it in here for you. So these three formula is almost the same, with only different is the different candidates, and these x's are different words that they are saying, and these are the posterior probabilities that we want to calculate. So in simply the only thing that we want to do is to find each of these probabilities and put it in this formula. So at the end we will get this, and we will calculate the posterior probability for both Jennifer and Gabriel. So let's start with the Jennifer. The probability of Jennifer, which in here we said probability of Jennifer gives a speech is 50%. So let's write this down. Jennifer is 0.5. The probability of Jennifer saying liberty is 10%. Let's write this down. Probability of liberty Jennifer is 10%, and also probability of Jennifer will say the word war is 10% again. Let's write it down. Probability of Jennifer saying the word war 10%. Okay, now let's write this probabilities also for Gabriel. The probability that Gabriel will give this speech is also 50%. Gabriel 0.5. The probability that the Gabriel will say the word liberty is 70%. Liberty Gabriel is 70%, and the probability that Gabriel will say the word war is 20%. Probability of war said by Gabriel is 20%. Okay, now we want to calculate the probability of liberty and war in here, which we don't have it based on the data that they gave us so far. So we have to calculate it before we actually put it in this formula. And the way we calculated this is we simply say, we say probability of Jennifer multiplied by probability of saying the word liberty by Jennifer. I can copy paste from here. Multiplied by probability of the word war said by Jennifer, and we will just add this down with the probability of Gabriel multiplied by probability of the word liberty said by Gabriel multiplied by the word war said by Gabriel. So let's just copy paste here. And let's call this P liberty war, which is this probability of liberty and war said. And let's print out the result, which is the probability of the words liberty and war being said in a speech. Let's multiply it by 100 to get the percentage. Which is 7.5%. Now let's calculate our posterior probabilities, which we can start by Jennifer. This formula is literally same as this formula. Now let's write this down. Probability of Jennifer liberty war. Okay, probability of Jennifer multiply by probability of the word liberty that's said by Jennifer multiply by the probability of the war said by Jennifer, and at the end we will divide it to probability of liberty and war said, which we will calculate it here. Now let's print out the result, which is the probability that Jennifer saying the word liberty and war okay, the probability is 0.07. Let me check this again. Probability liberty Jennifer. Yes, and now let's do the same thing for the Gabriel liberty war. Probability of Gabriel giving speech multiplied by probability of liberty said by Gabriel multiplied by the probability of war said by Gabriel. Then at the end we will divide it to the probability of liberty and war. Now let's print out the result. which is 0.93%. Also, at the end, for further checking, you can add these two up and the result should be 1. If it was other than 1, it means that we calculated wrong. As you can see in here, 93 and 7 is 1. Okay. Now this is some further resources if you want to learn more about the naive Bayes. And if you so far learn about it, you do not need to actually go for resources. Okay, now let's go to the last part of this Jupyter notebook, which is about spam detection. We use a naive Bayes theorem, which we already learned. But in here, we use a scikit-learn library, which it makes our job so much easier and it makes everything so much faster. In here, we use a data set that is for SMS messages, which is labeled either as spam or not spam. So first, let's load our data set. But before that, we will import a library for the pandas, which it will load our data set. Dataset pd read table. Now we will put the path to our dataset, which for me is dataset and SMS collection. Sorry, SMS spam collection. Okay, and in here we also have to say that these data are separated with tab. It's important to say this. You can actually understand this by just looking at the data itself. And we also don't want to have any header. We want it to be none. And as a column names, we can specify it here, which there's only 2 columns. We can call the first one label, which is it's either spam or not spam. And also the data itself, we can call it SMS messages. Okay, now let's take a look at it. Dataset.head 10. And as you can see in this column, we have our dataset, and this is our labels. Now let's just also take a look at like how's the shape of our dataset. Dataset.shape. And as you can see, there is around 5,500 examples in this dataset. Now, the next step is pre-processing, which in here the first thing we have to do is to actually map these two numbers. And let's start it by saying dataset, specify the column which is label, and you can say map. In here we have to use a dictionary. Let's say, for example, if it's ham, convert it to 0, and if it's spam, convert it to 1. Now let's take a look at our dataset. As you can see, all of these labels converted to either to 0 or 1. Next step is to split our dataset into training and test. Before that, we have to import the library. So sklearn dart model selection, import train test split. Okay, in here we have to say xtrain, xtest, ytrain, ytest, train test split, data set. The first we'll put this column, and then our label. We can also specify the test size, which we can say like maybe around 25%. Also say random state to be 1, so the result of my code and yours to be same, in case you wanted to see. So let's also see the shape of our training set. Training set size. Okay, now let's do the same thing for also our test. Okay, now we have around 4,000 for our training set, and also we have around 1,300 for our test set. The next step is to applying feature extraction. You do not need to know the exact thing in here because you will learn this more thoroughly on the second part of your nano degree. So in here, the only thing that you have to know that we will apply feature extraction called bag of word. So let's import. Again, you will learn this more thoroughly on the second part of the nano degree. Scaling dot feature extraction dot text import counter vectorizer, and in here we will initialize it, say vector counter vectorizer. And one interesting thing is that this counter vectorizer can also do the pre-processing steps. For example, we can say lowercase true, and also you can say your, let me show it to you, these token patterns, which it has the same thing as deleting the punctuation. You do not need to specify it, it will automatically do it by itself. You can also delete the stop words by just saying stop words in English. In here should be, I think. Okay. And now let's fit our initialize count vectorizer to our training set. Training data, call it count vector fit transform extreme. And also let's just transform our test data, no training here. Test data count vector transform x test. Now let's just check the how it changed our data set. We can just call the data frame and say our data is training data, and we have to convert it to array, and also say our columns are count vectorizer that get feature names, and let's just get like the first 10 columns. Okay, after applying the feature extraction, our data set turned into this. This is called bag of words, which you will learn exactly later on. And next, we will import our naive base and we will fit it in our data set. Let's do it. Scalar naive base multinomial naive base, and say naive. Let's first initialize it. Naive base. This is what we imported, and now let's just fitted base fit training data, which is our feature extraction. Also y train. Okay, now at the end we will let's predict all of the items in our test data. So prediction naive base predict the test data. We can actually let's print it. Prediction. Okay, and in here we want to convert the prediction, which is 0 or 1. We will come back to either spam or ham. So let's define a function for it. So you can say like prednom to text. Why not? Take the prediction, and if the prediction was wrong, return spam, and if it was wrong, return ham. Okay. Now we have this function. We will use it later on when we want to predict a random message. Now let's do it actually. Let's say just random. Let's say like we will predict the 16 item in our test data. So first let's see what was the actual message. The received message hx tests. We will check the 16 one, which is id message, and let's also okay our prediction which we can use the same function as here, and we would say just naive base dot predict xtrain I like message. Okay, I forgot to put the parentheses. In here we have to use the feature after applying the feature extraction, which this is not a x data but actually test data. Okay, and if you read through it, you can totally see that this is a spam message. Now let's just copy paste this. Let's say, for example, 6. Let's see what's the result of this. And yeah, if you read through it, this is absolutely ham, which ham is another word for not being spam. Okay, at the very last, let's just evaluate our model to see how it actually performs. And beside accuracy, we also use precision, recalling F1 score, which you can see all of the formula in here. And still we don't hard code it. We will import it from sklearn metrics. accuracy score, precision score, recall score, and a fun score. Okay, now let's say print accuracy. Accuracy score, y-test, and say the prediction, and at the end we will multiply by 100 to get the exact percentage. Now let's do the same thing for precision. Precision score, recall score, and also at the end F1 score. Okay, as you can see, we reached to a very high accuracy, precision, recall. Oh, I forgot to put this F1 and F1 score. And that is it. That is end of our Jupyter notebook. Hope you get any value from this. Thank you.